So, like I was saying, for two resistors to be in parallel, it's supposed to share the terminals or the nodes. As you can see, R3 is being connected to that terminal A and terminal B. So AZ is resistor 2 or R2 connected to A and B, even R1. So these are in parallel. But if I thought there was a resistor there, then this won't be in parallel with that because of that resistor. And if we are asked to find the total resistor seen through terminal A and B, we just do this will be parallel. Then for a star takes this shape. So we can say a star has this shape. It has a neutral there, neutral point. So we can just say this is A, B, C. There is a neutral. And here I can say R, A. Since A is this is near to terminal A. This has R, C because it's near to terminal C. That is RB. So the star network is also known as the Y, or can be taken as a T. So you can express this in terms of T. So it will be like this. So it will be like that. A B there, terminal B. That's A. RA, RC, RB. So no wonder it's also known by a T network because it takes the shape of a letter T, even a letter Y. So when you have to say converts to a Y network, you are simply saying converts to star. So here we've got a star and here is a delta. So you should be able to identify a star network and a delta network in a complex network, or having a complicated network. So we are done with the first objective. Now we'll go to conversion. How to convert from conversion from delta to star network. So I'll get the same shape, which is A, B. So it will be like this. You have to bear with me. I'll be brief and on point, because also I'm also considering new, looking at the issue of bundles. So there, it's supposed to be connected to, so to be in this way. So a star there, like that. A, B, C. This is RB, RC, RA. So aim is to convert from there to that. Meaning supposed to express resistor RA in terms of the resistors in a delta network. As you can see, a delta network being differentiated from delta is being differentiated from a star by these by the numbers. This one has cut numbers, this one has cut letters. So for us to derive how they came to the conversion or the formulas, we just consider the resistor, say RB, resistor seen through terminal A and B. I'll just extend so that you'll be able to follow. Like that. This is same point because there isn't any resistor, like I mentioned. So if we consider the delta, we can find to say resistor A, just imagine it as a vector, yeah, moving from point A going to point B. Yeah, it's supposed to move like this. Like that. Again, there are two paths. You can even go like this. That means these two will be in series, but parallel. So I mean, since I'm moving, like I mentioned on this one, we are sharing two terminals A and B, meaning this resistor is in parallel with these two which are in series. That is R3 in parallel with these two which are in series, R1 plus R2, which I can express like this. I multiply R3 by R1, R2, then over the total resistor. It will be R1 by following the order. So if I'm to expand, RAB will be that by that plus that by that. So it will be R1, R3 plus R2, R3 over R1 plus R2 plus R3. Then I can also express RAB from the Y network. The Y network. So I'm to consider, again, I can do like that. A, B. So here I've owned one path from A to B. I can move like this. So I'll pass through resistor A, then the neutral there to there. So it will be simply mean these two be in series. So I have RA plus RB. So I can even name this to be my first equation, then this as my second equation. Then by equating equation 1 and equation 2, meaning I have this one. That is, wherever there is RAB, I'll substitute with RA plus RB. So we have RA plus RB, which will be equal to this part. R1, R2 plus R2, R3 over R1 plus R2 plus R3 as my third equation. So similarly, if I were to look through terminal A and C, so terminal, or considering terminal A, AC and BC, of these two expressions. As you can see, considering terminal AB, we have these resistors from a star A and B getting to AB. So even our AC will be A resistor RA, RC equal to then RC, this AC. So this one will be in parallel with these two because I'm moving from A to C. So it will be R2 by R1 plus R3 over the sum, which I have R1 R2, multiplying that, we expanded R2, R3 over R1, R2 plus R3. This will be my fourth equation. Then BC, considering terminal B and C. R1 will be in series with these two. So it will be, I'm considering BC, so I have inside I have AB plus or RC, which will be equal to that in parallel with so it will be like this, R2 plus R3. So I have this expression, which will be R1 by R2 plus R1 R3 over the same, which is RB plus RC. This will be my fifth equation. So our aim is to express any of the legs there, RA, in terms of the resistors in a delta network. So for us to do that, we're supposed to subtract then at the end. So we can choose whichever we want to get rid of. So by considering these three expressions, that one and this one and this one. So what I will do, maybe we just consider on getting rid of say RB. So what we have to do is we are supposed to subtract. So subtracting equation 5 from equation 3, go have, so this side so it will be like this. I'm subtracting this from there. So it will be like this. Let's just focus on the what's on the left side of the equal sign. So this side to be that, then minus what's there. So minus B plus C. So these two will go, and I'll remain with RA minus RC on the left. Again, on the right side of the equal sign, I have this minus that. And remember, this is simply fractions, simple fraction. Let's just take for example, subtracting 2 over 3 minus 1 over 3. These two have same denominator. So here I have a 2 minus 1. So I'll just subtract what's on top, the numerators. I have 1 over 3. So if you can see, the denominator is just the same as that one. So I just simply, what I need to do is simply subtract what's on top minus that. So it will be R1, R2, R3 plus R2, R3 minus R1, R2 plus R1, R3 over same denominator. So as you can see, these are the same, and because of this minus, these two will go. So I will just remain with R2, R3 minus R1, R2 over R1 plus R2 plus R3. Like that is, I can say, equation 6. our aim is to express RA in terms of these resistors, delta resistors. But here I have a C, so I'm supposed to. So what I'll do is we're going to add. So adding equation 6 to equation so having RA and RC. The one having RA and RC is equation 5 or equation 4. So to equation 4. So adding these two, that and that. So it's like this, RC. So minus C 2, 3, R1, R2 over R1 plus R2 plus R3. It's supposed to be added to RA plus RC, which is this one, which is R1, R2 plus R2, R3 over just the same. As you can see, since we're adding, let's focus on the left side of the equal sign. There is a minus. So these two will add up, will be 2RA. Now these two, since they're the same and they have got different signs, they will be eliminated. So just have that on this side. Then as you can see, so is this side. RA, R1, R2, this combination is the same but different signs, so even this will go. So I'll just remain with it. So these are the same. So it will be 2R2 R3 over, remember what you're doing is simply adding fractions. Say 2 over 3 plus 1 over 3. So this will be common denominator 3. I'll just add what the numerators. So 3 over 3, which is a 1. So here my focus was just adding what's on top of the numerator, since the denominator is just the same. Then here I can say multiply by 1 over 2 to get rid of these two. Or I can just say over 2 over 2. So this will go. Therefore, I have RA being equal to, this is a 2, R2 over R3 over that. So mean I've managed to, so it's to be our equation 7. Then we just go back. So simply what happened here, what to convert is same as, let's just focus on it. Let's just focus here. This is a delta. It has the shape of a triangle. Takes the shape of a triangle. This is A, B, C, R1, R2, R3. Then I'll put a star network. Okay, let me just do this. This is RB close to terminal B. This is RA. This is RC. So if you can see what was going on is, what I'm supposed to do is RA is supposed to see the resistors which are connected to. So as you can see, RA is connected to terminal A. So suppose even to focus on the resistors of the delta which is connected to terminal A, which is these two. They're going to terminal A or being tapped from terminal A. Meaning these are the ones you're supposed to multiply. So multiply these two which are connected to the same terminal as RA. So R2 by R3, then over the sum of the resistors in a delta network. So like that, which is R2, R3 over. So this is a shortcut of converting delta to star. So similarly, RB will be, remember what you said, whichever resistance connected to terminal B, there are these two. So multiply these two, it will be R1 by R2 or R3 over the sum of the resistors in a delta network, as our equation 8. RC is this one. Resistors which are connected to terminal C is R1 and R2. So I have R1, R2 over R1 plus R2 plus R3 as our equation 9. So meaning since we've gotten all the resistors of the Y network, meaning we have converted. So we even do an example. Let's do an example. So our example is, suppose you are given this resistor or this network, a delta network, and you've been asked to find I'll just say A, B, C. Then here I can just say R1, R2, R3. This say R4. That's 4 ohms. This is 10 ohms. Then this is 6 ohms. So supposed to convert this to a star. That's the question. So supposed to remember star and delta, there are 3 terminal networks. So what I'll do is I'll just do like a simple, so it helps me to visualize where I'm going to. That's a star. So I can say this is RA, because it's one connected to terminal A. This is RB, this is RC. Remember, so supposed to solve for RA, RB, and RC. So remember, when finding RA, the leg of the star, supposed to multiply the resistors which are connected to the same terminal as RA, which is A. So there are two which are connected to, which is R1 and R3. So multiply R1 by R3 over the sum of the resistors, that and that, plus R2 plus R3. So it will be R1 will see 4 by R3 6 over 4 plus 10 plus 6. Here I'll have, that is a 24, this is a 20, which will give me 1.2 ohms. So we've gotten one resistor of the star. We go to RB. RB, where is it? This one. So there are 2 resistors of the delta which are connected to terminal B, which is that and that. So we're going to multiply those two, R1 by R2 over the same. R1 is 4 by 10 over, this is just the same, so I'll just put a 20. So it will be 40 over 20, which is a 2 ohm. We go to RC, the last resistor of the star. RC, where is it? This one. Which two resistors of the delta connected to terminal C? These two, not so. Which is R2 by R3. Then plus the sum of the resistors of the delta. So R2 is a 10 multiplied by a 6. This is just the same as those, so to be 20. So we have a 60 over 20. This gives us a 3. Therefore, or meaning we have our star will be like this. That's our star. A, it's there, B, C. So RA, which is 1.2, RB, which is 2 ohms, R3 or RC, which is 3 ohm. So we've solved for this question. So this is just our first part, converting from delta to star. Now we can go to delta star, converting back from star to delta. So for us to know how we can do that, we're supposed to use these three equations. This one, that one, and that one. We're supposed to use these. Or not these, not those, but we'll use these three. It's the one supposed to use. So we're now we're converting from star to delta. So here to involve us dividing, then we substitute. So we are going to subtract, or we are going to divide. So dividing equation 8 and equation 9 into equation 7. So that into that we'll have this. So it will be, so if you can see, I'm dividing that into there. So on the left I have RA over RB, which will be equal to, so dividing that into that. So also take you back to dividing of fractions. So it's just, we'll use the same example. 2 over 3 divided by 1 over 3. All we'll simply do is 2 over 3, then I'll exchange swap. If I'm changing the sign from a division sign to a multiplication, I'm supposed to swap this side. So it will be 3 over 1. These two will cancel. 3 there, 1, 3 there, 1. So I have 2 over 3, which is a 2. So in short, if we are dividing fractions, say 2 over 3 divided by 1 over 3, all you should simply do is get the numerator of the fraction on top over the numerator of the dividend, which is a 1. So this is what we're going to apply here as well. I'm dividing this into there. So I'll just get the numerator there, which is R2, R3 over the numerator of the second, or the dividend, which is R1, R3. As you can see, these are the same. So this will go. So our remaining RA over RB equal to R2 over R1. So here our aim is to express a delta resistors, which in this case the delta, which in this case the one having numbers. So here I'll make R2 a subject of formula. So making R2 a subject of the formula of R2 equal to, I'll multiply that by that, it will be R1 over RL, or RA there, then over this one, RB. So this is as my 10th equation. Then that into there, which is this into there. So on the left, I'll have RA over RC, which will be equal to, then remember what you said, dividing fractions. So I'll just get that one, it will be R2, R3 over the numerator of the dividend. So I'll have R1, R3. These are the same. So I'll have RA over RC, which will be R1. Then I'll express, I'm going to just a minute. Okay, just a minute. So there, okay, I think okay, we made a mistake here. So at first we're dividing this in there, so it will give us that. Okay, it's okay. Then here it's okay. Here is supposed to be a 2. So here is supposed to be a 2. That's a mistake because we're dividing that in there. Here we get this one, which is that one, then over the numerator of that one is R2. So what will go out away is these 2. So we remain with is R3 over R1. Then we express R3, or make R3 the subject of format. So it will be R3 will be equal to R1 RA over RC as our 11th equation. Then we're going to substitute these two equations. Then at the bottom, R1 just be intact. And R2, which is this, R1 RA over RB plus R1 RA over RC. So we can expand on top there, we can just multiply. So there we have R1 to be R1 squared. Then RA will be RA squared over B RC. Then here at the bottom on this part, I can, if I want, I can factor out R1. There will be a 1 plus, here will remain with RA over RB plus RA over RC. Then this again, we can go, so I just remain with R1 there. So to be like this, RA equal to R1 RA squared over 1 plus RA over RB plus RA over RC. Then again, we can simply, if we want to do, we can just say multiply all this by 1 over RA. So on the left side of the equal sign, this will cancel themselves. It will cancel with this one because this is numerator. This is numerator. This is a numerator. So so this will be 1 there. Then here will just remain with R1 RA over 1 plus RA over RB plus RA over RC. I can cross multiply. Now have okay, we have this. So maybe what you can do is we can, okay, let's just multiply. So it will be 1 plus RA over RB plus RA over RC equal to R1 RA. This again, I can get the common denominator, which should be RB, RC. 1 in there to give me that, so 1 by that to RB, RC. Then there, the remaining thing, RC. So it will be RC by that, RA, RC. There, remaining RB. So it will be RB by that, RA, RB equal to R1, RA. So what I can do is, so it will be like that. Then we can just a minute, we can, so there, we can do like that, or we can cross multiply, which should be okay. Maybe you can even simplify it, it's fine. Or what you can do is we can multiply 1 over RA throughout. It's just up to us what we want to do, but even at this point it's also fine. Or what you can do, you can multiply by 1 over RA to get rid of that remaining thing, R1. So 1 over RA, here I'll remain with so here I'll remain with so it will be more like this, or to be like this, RB, RC plus RA, RC plus RA, RB over RA, RB, RC. That gave us that. Okay. So here it will be. So here I'll remain with it. If I'm to divide that in there, these are the same. I'll remain with it. 1 over RA plus C. Here I'll remain with it. The A will go and the C, so I'll remain with 1 over RB plus this point RB will go, so I'll remain with RC, RA. Maybe just a minute. Sorry, forgot about this one. So if we want to include it here to just confuse, so I'll just get back from there, which was, so we have this expression RA being equal to R1 over RA squared over, this is a fraction, RB, RC, then divided by, so just say divided by, I'll just use this. So there on top there is, so it's like this, divided by that, divided by this, RB plus RA over RC. So these are fractions, can express in terms of fraction to be a squared over RB, RC. So we can find the common denominator to be RB, simply multiplying these two. Then that in there, it's this, multiplied by that to be RB, RC plus that in there, I'll remain with RC to be RC by that, RA, RC plus this in there, I'll remain with RB to be RA, it will be RA, RB. So if we were to swap, to change the sign to implicit sign, it's supposed to swap this side to be like this, RA, R squared over RBC multiplied by RB, RC, RB, RC plus RA, RC plus RA, RB. This will go. So it will be, this RA to be that to be R1 RA squared over RB RC plus RA RC plus RA RB. What we can do here is maybe we can simply cross multiply, or we can multiply everything by RA to get rid of this one and that one. So, or simply say we divide both sides by RA. So here our remaining thing 1 over 1 equal to, there our remaining R1 RA RC RA RB. I can cross multiply, however, R1 RA being equal to those. I can simply start by this part RA RB plus RA RC plus RB RC. Then I'll divide over that. So remaining thing R1, which is the side of one side of the one resistor of the delta. So there our remaining thing B RB plus there RC plus RB RC over RA. So this is our conversion expression of R1 in terms of the star resistors. Star resistors. So in short, the shortcut of doing this kind of conversion from a star to a delta, as you can see, R1 is connected to two terminals B and C. So I mean, for you to convert to express R1 in terms of the star resistors, supposed to get those two resistors of the star which are connected to the same terminal as R1, which is RB and RC. Then what you're supposed to do is say R1 will be equal to the two resistors of the star connected to terminal where terminal RA is connected, or resistor RA is connected, and B and C. So B and C, there is that and that. So you're supposed to add the two, RB plus RC plus, then you multiply these two, RB RC, then over the remaining resistor of the star, the one you haven't used, which is RA. Or you can divide over the resistor which is opposite the same resistor you are looking for, which is part of the delta, so which is RA, the one we got there. That's a shortcut. So use the same. So we're going to focus on the same. So even similarly for R2 and R3, we just say R3, R2. So we're going to focus on the resistors which are connected to R2. R2 is this one, connected to terminal A and C. So we're going to get the two resistors which are connected over the star which are connected to terminal A and C, which is this one and that one. So supposed to add the two. So it will be RA plus RC plus, then it's supposed to multiply these two to be RA RC, then over the resistor you haven't used, which is RB. R3 is this one, connected to terminal A and B. So supposed to get these which are of the star which are connected to B and C, or B and A. So it's RA and RB. So it will be RA plus RB plus the product of the same over RC. So this as your equation, say equation Okay, just equation A. This is equation B. This is equation C. So these are the delta resistors, R1, R2, R3. So let's do an example. Let's do an example. Use the same example you used, because in the previous example we converted from delta to star. Now we're going to get the same star we found, which is this one. It's like this. A, B, C. RA, RB, RC. RA is 1.2 ohms. Use a blue pen. 1.2 ohms. RB it's 2 ohms. RC it's 3 ohms. So supposed to convert to a delta. So I'll do a simple delta to show you. Then do that. So you can say this is to be, say, R1, R2, R3. So remember from our shortcut how to solve for delta resistors from a star. So we're supposed to find R1. So we said we're supposed to get the resistors which are connected to terminals where R1 is connected, which is A and B, which is this and that, A and B. So it will be RA plus RB plus multiply the two, RA, RB over RC. RA it's 1.2 plus RB it's 2 plus R 1.2 by 2 over 3. So this will give you 3.2 plus, that will give you 2.4 over 3. So 2.2 plus that is this Hadley calculator over 3. We have 0.8, so 0.8 there, which will give us, if we had to add this, to give us a 4 ohms. We go to R2. R2, which is this side. The star is connected to where terminals of R2, it's this and that. So RB plus RC plus multiply the 2, RB plus RC over RA. RB it's 2 plus RC it's 3 plus 2 by 3 over 1.2. Here it's a 5 plus 6 over 1.2. So 6 plus or 5, sorry. So we have 6 over 1.2 is a 5. This will give us a 10. We go to R3, which is this one. So these two are the one connected, RA and RC. So RA plus RC plus RA, RC over RB. RA it's 1.2 plus RC, it's a 3 plus 1 by 3 over 2. So this will give you 4.2 plus this is 3.6 over 2. This will give you 3.6 over 2, 1.8. So this will give you a 6 ohm. So these are the resistors of a delta. And then you can even draw your delta as this. So your delta will be there. Those terminals A, B, C, R1, 1 if containers a 4, R2 if containers a 10, R3 a 6. Just like the way it was here. This was our delta. This question we were converting from delta to star, and here we are doing vice versa from star to delta. Okay, let's do an example. So this question, the question was, so there is a question, find the current in the 7 ohm resistor in the network using star delta conversion. So the things we are just from learning. Remember when you talked about an open circuit, you said an open circuit there is no current which goes through, but there is a voltage. You can measure a voltage across there, and there they are saying voltage across this is 115. Then let's just take a look at this network. You can see to say this resistor, they are in series. There's a terminal there, even these are in series, so you can redraw this. Remember, series resistor, you can additive, you can just add them. So that plus that will give you 15, this and that will give you 8. So it can be drawn like this. So it will be there, go off by point A, the 6, even a 6 there, a 4, and there's a 15, a 17 there, our load resistor. So these two will be like that. There is B. Then this point is going back to the source. So is this point. So here I can just say it's just the same. Here there is 115 volts. 17 there, a 41 there, a 6 there, 15 there, 15. So even this one will be 15 because it's 11 plus 4 is a 15 ohm. So here even here to be 15, here to be 8, 2 plus 6, 6 there. So you can see this is a triangle, which is a delta. So here I can even say, I can just say put n, whichever that I can put. So I can convert this to star. So I have this shape. There. So even this is part to be like that. But simply I can just say this to be RA, RB, RC, RE, RD, RE, RF. So I can solve for. So we're supposed to convert RA. So we're converting RA, which is a star, it's a delta. We said we're supposed to multiply the two. The one connected to the same as this resistor, same time as this resistor. So multiply 8 by 6 over the sum of the delta. So it will be 6 plus 8 plus 6. Here's a 48 over 6 is 12 plus that is 20. So it should be, here's a 24, is a 10. So it will be 2.4 ohms. 2.4. So 48 over 20, 2.4 ohms. RB, it will be, so this one, two resistors there and there. So I can even name, I can just say, if I want, I can just say RP, which is 2.4 ohms. This is a 5 ohm. Here's a 115 volts. RK, RJ, which is simply adding these resistors. So it'll be 2.4 plus 41 plus 5. This is 46 plus that to be 48.4 ohms. RK will be 1.8 plus 17 plus 5. Here it's see, it went to here to be 23.8 ohms. 23.8 ohms. 48.4 ohms. These two be in parallel, so we can simplify the two. So we have this network X, Y there, and then there it will be 5 XY. So these two will be in parallel, so I'll just say